Hello, everyone. Today, I want to talk about how we're going to allow billions of people to build billions of solutions using a concept I call documentation as code. First, we're going to watch an educational video.
Right. So the compression and expansion of the longitudinal waves cause the erratic oscillation, you can see it there, of the neighboring particles. Guess what is it? What is it?
Can I play with it?
No, you can't play with it. You will enjoy it on as many levels as I do. The colors, children.
Yeah, just like in this educational video, many presentations about AI and agents look really cool when the presenter is presenting them. But when you go and try to do something on your own, you're just not enjoying it on as many levels. And in this presentation, I'm going to try to focus a little more on limitations so that we can avoid this highlight reel effect. First, I want to see this idea. What I mean by documentation as code is any solution where instructions written using natural language are executed by an agent. So think of it where a Python interpreter is executing your Python instructions line by line. Here, an agent is executing your uh, instructions written in your native language. Let's talk about what are agents. It's according to the dictionary, a person who acts on behalf of another person. And the Agentic AI is a software that's driven by LLMs and it uses tools to do things for you. And tools are just pieces of code that the LLMs know about. When you try to build your own agents, the learning curve is high. The LLMs produce excessive output, which is hard to modify. And when it's wrong, it's hard to forgive them. But I'm going to provoke you to think a little differently. And a big part of this presentation is to get you to think differently about the place of agents in our world. And what if it's okay? What if we're not looking for an answer? And I can talk about that for about 10 minutes. What if it's okay to make mistakes? I know a good therapist who can talk about that for hours. Maybe agents are not supposed to solve every problem. Another way to look at agents in our world is through evolution of code. Started out with tubes, punch cards, assembly tapes. Then we got to higher level languages, frameworks, meta frameworks, no code where a graphical user interface builds things for you. And people were able to build millions of products. But now with the advent of useful LLMs, we have documentation as code where you just write the requirements and execute. And with that, we'll be able to have billions of people building billions of solutions. One limitation that's hard to overcome is the runtime performance is going to be slower than a fine-tuned algorithm. We're going to get philosophical here for a second and say that the solution is a function of the problem. And with that in mind, we're going to think of categories of problems we can solve with the documentation as code concept. One such category is anything where time to build is high, but immediate benefit is low, like a proof of concept that nobody is going to like. It's going to take a while for you to build, but potentially it's not even going to get picked up. Personal projects that have small audiences, internal tooling because ain't nobody got time for that, and uniquely personalized experiences. And we're actually going to talk more about that with a little demo. Uh, we're going to have we're going to be building our GitHub dashboards for our manager who keeps coming to us saying, hey, you're a superstar. You can get this done in 30 minutes. Can you give me these statistics real quick about our GitHub repo? But the requirements keep changing. And we're going to start with a traditional solution and then transform it to a disk solution. So our original requirements are for the most prolific author of GitHub issues, give me the number of issues they have created. Given the author's issues, I want to know the number of comments that the same author has made. So it looks like we're looking for some engagement level statistics about that author, prolific author. So our front end is just going to be a little table that's going to get the data from our data endpoint. And it's going to look like that. The back end, I'm going to focus on the different kinds of algorithms you need to, provide that data. And it's loops, more loops, and a data structure that helps, a data structure that the front end can parse and produce our table for. And it comes out like that. Pretty underwhelming, but those were the requirements. So we're going to go and try an agentic approach just because the requirements keep changing, and we're hoping the agent will help us, you know, not have to deal with this every week, 30 minutes at a time. And we're going to use a React agent where a React agent is a reason, act, observe, iterate loop. It was introduced by this white paper. We're going to use a pre-built LangGraph React agent which is built for demo purposes, and you probably would want to write your own React agent for a production use case. The way a React agent works is you pass in a request to the agent reasons about your request, and may decide to execute some tools. So the tools get executed, and the tool provides some output to the agent. The agent reasons again and may keep going in the cycle until it gets enough information from the tools to provide satisfy the request and end the cycle. So this, let's implement a quick React agent here. We're going to have our data structure. And instead of the algorithms, we're just going to have our prompt. These are our requirements. And we also added our GitHub repo so it actually knows where to look for that author. Then we're going to have our agent code. And we're going to have an LLM. We're going to have a GitHub MCP. We're going to combine them with this React agent from LangGraph. And it's going to have a structured output, and the rest is just a structured output boilerplate. And the result is the same, but slower. Okay, quite underwhelming, but let's see if it can accommodate some. We're hoping that it can accommodate changing requirements. Let's look at the code again. And we quickly recognize that the data structure is coupling our front end and our back end. And if the requirements change to require new data or new, even nested data, then we're going to have to write more code. Of course, the requirements change, and now we want to actually see the text of issues and comments. So our code would have to change. So how are we going to change it? We're going to say, okay, to avoid these kinds of changes in the future, we have to put the responsibility of generating the front end and give it to the agent. So we're going to change our system prompt and tell the agent that it's just generating HTML and nothing else. So now it will gather the data and output it in a format that we describe or that it decides is good for us. So then our endpoint is basically there's no code. It's just loading up the prompt from the file. And I've added a little Bootstrap CSS to give it a little better look. Everything else is just our requirements. And we have something that's a little better. And let's see if it can accommodate other requirements. So below the comments, so these are additional requirements coming in. Below the comments include a link to the issue on GitHub and use accordion style display to make it easier to scroll through the entries. Okay, we're gonna actually go and run this in a Jupyter notebook and see this. So this is the prompt. I added some style for accordion, and we're gonna actually go ahead and run our server. You can see a little more code here about the GitHub MCP setup. See. Gonna run Chrome so that we have two different browsers. And all right, so we got our request, which is just our requirements. The agent reasons and decides that it needs to list issues from the list of tools. The tools come back with the list of issues. And then, but the list of issues doesn't have information about the comments. So we have to go and uh, make a call for each issue to get the comments. So these calls actually happen asynchronously at the same time. And our result should be ready now. Now we got our accordion and we got a link to the actual issues. All right, at this point, I'm hoping that everybody's thinking enough with these lame contrived examples. How could I actually use it in my, for any of my use cases? All right, so let's take this up a notch and solve something that resembles a real life problem. So we're going to be organizing a hackathon. And our hackathon, we're going to have some reviewers. We're going to also point up to our repo. And we're hoping this agent will help us deal with the 500 plus hacks that were submitted for our hackathon and help us organize reviewing process and, just facilitate our processes. So we're going to select some data that is readily available from the GitHub UI, but we're also going to um, include pieces of data that require some LLM usage, where these pieces of data are derived from the text of the repo, of the issue. Uh, they're kind of these dynamic parameters that we want to see in the list of issues, which we cannot get anywhere. There's no UI that allows us to um, view this information, extract and view this information. And here, with just a little bit of text, we're going to be able to do it. So I'm going to run it because this one takes a minute to run and then go into how it was implemented. So we're going to run this guy. And once it starts, I'm going to execute it. It's going to pretty much do the same thing. It's got that prompt, then it lists issues, and then it does other things. So here I've introduced another agent, which is an act agent. This is the one that provides interactivity. And I'm not sure, I didn't get this to be production level ready, but it's pretty cool for demonstration purposes how you can have two agents talking to each other with no structure and just using unstructured communication protocol. So the act agent is just basically tool select and execute. Most of the instructions here are telling it not to produce excessive output. Let's look at our system prompt has changed. So we introduced this act endpoint behind which that act agent sits. And one of the key instructions here is that we're providing it what the act agent expects, and it's just a string. It's not really structured output, but it's helpful to provide it an example of what the data that is needed for it to work. All right, let's see it if our output is ready. So we've got our unique perspective into this GitHub repo. And we've got our derived data here. We got tags that we were specifying that we want to see tags. And we have assignment. So we're going to go show you, it looks like everybody is assigned, but let's unassign. Ah, unassign? Can I unassign? No, cannot unassign. But I can unassign here. Mm. And we're not gonna wait for another generation. I'm just gonna say assign. It's gonna be assigning. And when it succeeds, it's taken a little while. So now let's see if we got another assignment. Okay, so it was self-assigned just now. Removed and assigned. All right, and it also decided to leave a comment. So that's why it took a little while. And that's also another reason why I consider this not to be a production ready as is, because it sometimes decides to do things you didn't expect, like leave a comment, which is benign, but could be interfering with things. All right, so that is the end of the demo. Let's go back to the presentation. So let's talk about some limitations. If your requirements changed in a way where you don't have the right tools, you still need to write some code or plug in a new MCP server. You need to learn about agent specializations and limitations to work efficiently with it. Runtime performance is slow. We got inconsistent outputs. Sometimes it blasts overreaching solutions, and incremental refinements are challenging. Engineering rigor is not even part of this presentation, and it's not free. And at Breba, this is the stuff I'm working on, making sure we can have tools dynamically plugged in where you don't need to write new code. You just simply drop in documentation for a tool or provide a URL to a new MCP server. Stateful agents, so where checkpointing, persistence, and caching will help with the iterative development and output consistency. Human in the loop is unavoidable because the human is providing um, the requirements and verifying the final result. I challenge you to find any human who can follow a process that has 50 steps in it and provide a satisfactory result at the end without asking any questions. So we want to make sure human in the loop is built in and also assists with debugging. And to kind of summarize, in less than 90 lines of code, we've got a unique perspective, not just into GitHub, but I would argue into the internet, because this agent, given the right tools, let's say a search tool, a web search tool, or another MCP server, can provide you with a unique perspective into different parts of the internet, given the tools that you give it. And it will help you to avoid ad-driven platforms because the agent filters your results, curates them just for you, unique perspective into the internet. No more attention harvesting platforms because again, the agent will filter those out, and the algorithm, that oftentimes keeps us siloed. You now have the control over the algorithm because you specify what you want to see, how you want to see it. And in conclusion, with the disk, users will just write the specifications and the agents will run it, helping us to solve rarely, categories of problems rarely solved before, like developer setup instructions. That was supposed to be humorous, but looks like that's a little close to home for a lot of folks here. Maybe a small website for your party that's going to be attended by 20 people. Tennis league at work, and that's going to fall apart when you find a new job and move away. Behavior tracking app for your child that the teachers are just not going to use, and billions of other unique solutions to highly personalized problems. All right, thank you.